Welcome to Taming the Timing Beast and PTP Mismatch and Smarter Sync Strategies with leader experts Steve Holmes and Kevin Salvidge, who are going to be drawing on real world industry experience and sharing that with you today. You know, we've seen that PTP being the backbone of 2110 synchronization, lots of broadcasters have discovered that what might work well for telecom networks can lead to unexpected situations and behavior in their broadcast facility. So today we're going to get into how and why PTP reference mismatches occur, what triggers unnecessary switching, and how to recognize early warning signs before they escalate into service affecting problems. So stay with us. Over to you, Kevin and Steve.
Cindy, thank you very much.
Yes, and welcome everybody. We
And is it
appreciate
too
your
late for a
help.
Happy New Year?
Yeah,
It's
never,
the
never.
it's the first one of the year. So thank you everybody for joining us. So
Yes.
for those of you who don't know us, I'm Kevin. Here's Steve, and here are our contact details on the screen. We're running a pretty tight schedule on this one, so if you do have questions, we'd recommend you put them into the chat. Anybody who's joined us before, you will know that we will come back and answer your question. There's no such thing as a stupid question, but there is a stupid answer. So it doesn't matter what it is. If it's something you're not sure about, put it in the chat. We will pick it up and we will get back to you. Or if afterwards you think of something, you can see our contact details currently on the screen. So here we go. Taming the timing beast. Um,
Yeah, there's a lot of things that can take place in this crazy world of having two different sync systems.
there are, and we're starting to see a lot of broadcasters who are being approached by consultants from the telco saying, well, we've done PTP, we know what it's about, we know how we make it work. Um, but there are quite a few things that are different between our world and their world. And in the next 50 minutes or so, Steve, we're going to try and go through those, aren't we?
Yes, yes, most definitely. So,
So let's start off with, as we said, the misalignment of telecom design methodologies when it comes to broadcast requirements. And probably the most obvious one is the timing philosophies. In the telco world, good enough is good enough. But if you work in a broadcast world, you know that we're now dealing with frame accurate requirements. Cameras capture
yeah,
frame
well,
accurately.
even beyond that, for cutting things for graphics, we need pixel accuracy.
Yeah.
So, I mean, it's beyond frame accurate. So,
So we have one thing in common. The telco world use an IEEE standard 1588 and the broadcast specification or profile SMPTE 2059 comes from it. Both use the same clocks, but with a very different kind of rules of engagement. And these are just some of them I picked out, Steve. The fact that with our telco world or 1588, the epoch is flexible, whereas obviously we have a very strict definition. We have to handle video phase and audio alignment. And that's before, as we said, we moved to the pixel accurate requirements that, involved in clean cutting and editing
yeah.
in this world. So think of IEEE 1588 as the language and 2059-2 as the broadcast accent, the grammar, and the strict pronunciation guide that's associated with timing. Next one, and we've spoken about this at length in the past, is the traffic profiles, bursty packets versus deterministic media. And we've done sessions about how SMPTE has a 2110-21 traffic shaping and timing of video section that goes into great detail to manage the transfer of packets across these networks. Because what you have to remember here is that it takes just one drop packet, Steve, doesn't it, to get an image like that?
Yeah. A lot of people don't realize that one IP packet is a quarter of a line of video in 1080 video, 1080i or 1080p. And switches do not pass corrupt IP packets. So the entire packet is dropped. Where in SDI, all it is a hit to a single pixel. And out of 2 million pixels, one pixel changes value slightly and it'll never be seen. But in the world of 2110, it is devastating. And it's the whole reason that we run -7 and have two networks putting out the exact same data, and one is not primary, one is not secondary. They're both primary networks putting out the data. And if a packet is missing, we just grab it from the other side and keep on going.
We'll get a little bit ahead of ourselves here because that's coming up
This
in a
is
minute,
true.
isn't it?
This is
It is.
true.
So,
Welcome to me.
but obviously, if you've got a network and you've got traffic shaping and management across it, you'll get deterministic media flows and your packets will be correctly reassembled at the receiver and you will have beautiful pictures like we have on the screen at the moment on the right hand side. So I found this quote online and I think it's almost like one of the Ten Commandments. Thou shalt not drop any packets, not at the sender, not in the network, nor at the receiver.
That's
Remember that.
absolutely correct for video network, because there is no backup. We don't do TCP where we can go NAC a packet, go resend it. By the time the packet's missing, that piece of data, that frame is gone. So that's why we can't do that. I mean, it's coming in at 1.5 to 3 gig per second, continuous.
Yeah. So, as you alluded to, Steve, the next bit is 2022-7 operation. Because in the world of 2110, it's not a main and backup network. It's load sharing, isn't it? They're both active.
They're both 100% active, and the packet picker in the receiver is just taking the first packet that shows up at the door. So with network probability, the loading would be on a perfect network would be a 50% loading. It's taking 50% of the data off of the red network. It's taking 50% data off the blue network, as we typically call the two networks.
Yeah. So this brings in another challenge that our broadcast colleagues are starting to see, that people are talking about completely air-gapped systems. Now, this brings with it a number of challenges, doesn't it, Steve?
Yes, it does. Some major challenges.
And the first one of those is that endpoints are not mandated by IEEE 1588, SMPTE, ST 2059, or 2110 to perform the best master lock algorithm to choose the best grandmasters or the best grandmaster. Some lock to a bias port that is receiving syncs, some lock to both an average.
Yes. And some
And
may do the BMCA, but you never know.
yeah,
And in this case of that picture, you also have two Grandmaster IDs coming at you. And some receivers get really upset when they don't have the same ID.
and this can lead to the possibilities of what's referred to as a split brain PTP situation. Um, and if you get into this world, you really do have to understand your PTP networks, and you're going to need some serious test and measurement equipment to fault find and diagnose what's going on, Steve, aren't you?
You are. And you got to remember, these are coming in IP packets, and the PTP will now be slightly jittering between the two networks by at least the width of 1 to 2 packets moving with what's coming in just due to network topologies and how network switches
Mm.
work. And some devices don't like that amount of jitter.
Mm. But fortunately, there is a solution.
There is.
And a lot of the larger systems that we're seeing deployed and operational have a PTP distribution layer. So this is the only connection between the red and blue networks, and it's carrying the PTP messages. And Steve, as we discussed before that we started this, that's not at the level that the video's at, is it? So it's not going to.
No, no, the video never gets above that spine. The video is always from that spine down to the leaves. This is only for PTP, and this way the two grandmasters can talk to each other and perform the BMCA and say who is the best grandmaster based on how you have set it up.
And this then leads us into the next piece. The whole reason you're looking at 2110 is because it's going to give you that ability to grow your system, expand your operations. So at some point, that initial system that you've designed and deployed and are now operating, you're going to want to expand. So
Yes.
on the right hand side, the PTP distribution layer is pretty simple to expand. You simply connect your new spine switches to the distribution layer. On the left hand side, though, that's a lot more challenging.
Yeah, how
And
are you going to get PTP into those two new spines?
and trust me, you want to keep this as simple as possible because there's enough complex stuff going on without you building an extremely complex basement and foundation of your system. Designing resilience and redundancy. So as we've talked about on previous presentations, the best master clock algorithm or BMCA is used to identify and select the Grandmaster. Now, in the telco networks, BMCA is often left largely is kind of automatic, assuming homogeneous clocks and well-defined timing hierarchies. But in the broadcast world, that's dangerous, isn't it, Steve?
Yeah.
Because we may well have a broadcast facility that has an IPOB truck connected to it, that then has fly packs connected to that. And you may, if you're a larger production, maybe have a third party studio connection. This architecture needs to be designed so that temporary networks do not mean clock quality varies widely. So you must use the best master clock algorithm to kind of design your networks. And one of the key tools for that is the priorities. Priority fields are kind of used within the telco world, but are they really understood? Because we've chatted to engineers and they say, well, BMCA, the Grandmaster is the best oscillator. That's the one that wins out. But in the broadcast world, you want to design your architecture so you know exactly what's going to happen when a failure occurs. So if we take this into a leaf spine architecture here with a PTP distribution layer, and I've got two leader LT4670s sitting at the top, with the one on the left being the Grandmaster. But you'll notice that I'm using priority 1 to segment this network. So my 4670 is priority 1. My PTP distribution layer switches priority 1 is also set to 10. But then you can see that the spines are set to 20 and my leaves are set to 100. So I've segmented my network now. And I'm using priority 2 to basically build in redundancy. So as you can see now, If I lose my Grandmaster that is priority to number one, my backup becomes the Grandmaster because its priority two is set to two. And if I lost both of them, we'd move into the distribution layer switches. So as we've discussed in the past, Steve, it's well worth building your network and basically carrying out some comprehensive failure tests to make sure that it does trip and fall over exactly as you expect, isn't it?
Yeah, because you don't want to run into this on a live network that you've never tested, and make sure that you have the hierarchy set how you think it should be and things don't fail over correctly. And you don't end up with one of the issues that you're about to talk about coming up here.
Oh, our good old friend, PTP domains. Again, PTP domains logically separate timing systems on the network. And this is where one of our favorite bugbears appears, isn't it? I've seen a number of designs from telco consultants where the default domain is zero and they're just using priority one for control. But in the broadcast world, if you haven't sat through any of our presentations and you remember one thing from today, don't use domain 127 because that's the default domain. And that could mean that you get rogue grandmasters, unexpected phase jumps, audio clips, lip sync errors, basically unexpected quality of service issues.
Yes, because then it gets into who's got the lowest MAC if everything else agrees, and you don't have control of that. That another company's MAC actually may be a lower number than what your Grandmaster is, and
Yeah.
it gets put on the network, and all of a sudden takes over, and it may not be GPS locked. So now you're locked on maybe a decent internal oscillator, maybe not.
Well, we've also seen them, Steve, haven't we, where there is an oscillator that's locked to a GPS reference is not being used because of the way the priorities have been set up.
Yeah.
Obviously, at this point, it's also worth mentioning domain zero. So for any of our audio friends out there with audio over IP, you're probably going to find that domain's already been used.
Yeah. And Dante, AES67 all use domain zero. So it's just best to stay away from it in your broadcast plant so that you know when you're on looking at PTP what you are looking at and what it's for.
Yeah. So as we said, telco engineers optimize for accuracy and resilience, but broadcast engineers optimize for phase, determinism, and predictability. And again, it's great the internet because you can find great quotes from people, but PTP domains are a convenience in the telco world. They are sacred ground in the world of 2110. Which leads us to this real world example, Steve. I think that you came across, didn't you, with a customer who's
Yes.
bringing should we say PTP house reference into their 2110 world.
Yeah. Now you may have a rubidium, basically a nuclear oscillator, and have a very, very stable PTP source, especially on people that are just now migrating to 2110. And you want to use that super, super stable uh, reference source when GPS is lost, which makes sense. And you can then add your sync generators, or 4670s in this case, to be followers of that PTP source, but you don't want to have them reproduce the same domain and put that same domain off of those units back into that distribution layer, because you just created a loop and all PTP will go down because it just has a loop and everybody's chatting to themselves, and you've just completely destroyed PTP on that distribution leg right there.
So we're going to remove domain 44. As I said, if it's worth telling you once, it's worth telling you twice. Don't change it to 127 or 0.
Yeah, just some other random number. Domains are just random numbers that you pick that are going to segment this PTP from any other PTP. And don't ask me why, but years back, I just grabbed 44. My office and everything I deal with here, it's 44. It's just a number
Ah.
I grabbed.
And as our two offices come together for IBC and NAB, mine's running 44 as well. So
Yep.
excellent. So obviously, another challenge that our broadcasters face, unless they are extremely lucky and they're moving to a brand new shiny IP facility, but even then, I'm guessing there's going to be some SDI video floating around in there somewhere,
Yeah.
is managing an existing SDI infrastructure. So the simplest and best deployment is to have both your SDI infrastructure reference sources and your PTP coming from the same sync pulse generator. And at Leader, we have the LT4670, which has a single oven controlled internal oscillator, and connected to that are all of our reference sources. So Black and Burst, tri-level sync, SDI test patterns, digital audio, SMPTE 2110 test patterns, PTP generator 1 and 2. So the beauty of this device is it can lock to GPS, it can lock to house Black and Burst and PTP. So if your broadcast system is part of a larger infrastructure project, we can take those references and ensure that they are locked and in sync with the rest of your facility.
Yeah. Because if you are that system that we looked at before, where you do have a rubidium crystal on a different PTP source, locking this generator inherits that accuracy. So you're not going to degrade that accuracy. This will inherit that accuracy and reproduce it. But the beautiful thing about this, if something was to happen to either the GPS or the PTP coming into this sync generator, your black burst and your PTP will never be out of sync with each other. Your AES won't be out of sync. Your SMPTE, your test patterns, your SDI and 2110 test patterns. So having your SPG, your sync pulse generator, produce all patterns for your video network, stop any issues that you would get from some type of failure in your sync source, causing your PTP and all of your blackburst and everything else from drifting apart from each other, which is really bad.
And the other great thing is, as well as that stay in sync capability, is that when the GPS or PTP reference returns, rather than doing an abrupt switchover, we have a slow sync capability. So now it gradually pulls them back to that reference time.
Yes,
So again,
it does it as fast as it can without causing color shifts or audio whoa and pitch changes. So it will take a little bit of time if it's been out for several days to actually pull the sync all the way back. You can go in at 2 a.m. and hit a jam phase and jam it back in the middle of the night or something, but it will not do a 360 whirl to go resync itself. It'll just slowly pull itself back into sync.
and it's doing that with the PTP as well. So,
Yes.
our broadcast engineers with SDI are familiar with this on their analog black and burst and tri-level sync, but this is doing it with PTP as well. So basically, it is the one of the essential building blocks of a PTP system. But that then leads us into another challenge that hybrid facilities have come across, And this is what's known as a reference mismatch. So again, as I said, it's highly unlikely in a telco world that you're going to run into SDI video with IP. You're going to have a single reference source. But we've basically got two of them. So we need to design a system that can accommodate the potential changeover due to either an SDI or IP reference failure. So here is a very traditional drawing, isn't it, Steve, of a pair of SPGs with a changeover unit.
Yes. So these are providing the PTP to the 2110 network. They're providing all of the baseband signals to the ECO, to all your distribution for SDI and AES, LTC.
So what we've done at Lido is we've had now for many years with our sync pulse generators a cable that linked LTC to the emergency changeover unit. But what we've done is we've added some additional cabling now so that it can monitor basically failover conditions. So kind of view this like as a sense cable that connects between your two LT4670s and the changeover unit. And it's permanently now monitoring the health of your black and burst, your PTP, and all of those so that we avoid a reference mismatch. So what we're going to do now is we're going to go through examples of how this works and scenarios that take place. So here we have a setup, pair of LT4670s, an emergency changeover unit, and the system is matched. And basically, all of the references are coming off of the top LT4670. It's the Grandmaster. Basically, life is good, isn't it, Steve?
Yes. It's how we sit 99% of the time.
But then let's take the most common kind of PTP failure, which is a change in clock class.
Yeah. If you lose a GPS antenna due to a lightning strike, the antenna just quits. Somebody cuts the cable. The two SPGs, the second SPG is going to notice that your clock class went from 6 to 7 because it went into holdover, but the bottom SPG is still GPS locked, so it's still clock class 6. So it's going to go from passive to active. The top one's going to go to passive, and now all of your PTP is coming off the bottom generator, but all of your baseband signals are still coming from the dude on top.
Yeah. And there are a lot of devices out there that do not like operating in this scenario, Steve, aren't there?
No, because there will be a fractional drift eventually on that baseband signal because you are on the internal oscillator that is not locked to GPS. And over time, several hours, they are going to drift apart from each other.
So, how do we get around this? Well, what we've done is we've added onto the LT4670 the ability to monitor the best master clock algorithm. And what we can do is we can force a failure on one of the six independent black and burst or tri-level sync outputs.
Yeah, you have six of them. Typically, we take number six, the one you're probably not using anyway, and cause it to fail.
And as soon as that fails, the MCA has already taken over and puts the backup, the bottom unit as the Grandmaster. And now our traditional black and burst tri-level sync digital audio fail because we've forced the changeover unit to become active.
And the other signals will never see it because all of the switching for black and burst tri-level AES is all done on electronic relays, which are instantaneously switched, and nobody even takes a hit on the baseband side.
Yeah. So if we go back to our match scenario, the other obvious failure here is a traditional black and burst failure. And every broadcast engineer out there knows exactly what now happens. The emergency changeover unit kicks in, and we have another reference mismatch because
Yes.
the changeover without our cable and setting does not know what's going on with the best master clock algorithm. So, as I said, we've added a parameter in the setup now where you can set the BMCA link to changeover, so that now when that occurs, we basically adjust the priority one setting so it becomes the Grandmaster.
Yes. We force a soft change, so it's not a loss of signals. It's a soft change of just priority one, and all it does is does a soft walkover to the other Grandmaster, which is perfectly in time with the top Grandmaster. And other than a Grandmaster ID change, nothing changes with PTP. It's perfectly in phase. It's perfectly synced.
So that then leads us into the next bit, manually resetting the system. So this is probably one of the biggest differences between the telco world and the broadcast world, where in the telco world, we see lots of things like self-healing systems. And again, it reverts back because they're main and backup. You want the main to be the main, and as soon as it's serviceable again, the system switch over. But anybody who's worked in a broadcast world, or especially live production, will know that if you switch to the backup SPG, even if you fix the issue on the primary one, you do not switch that back until the end of the production. We do
Yeah.
not want unnecessary switching going on. So
Yeah.
we've taken that philosophy and we've brought it to apply it to both Black and Burst and PTP. So you'll notice here now, when I've got the link to changeover set, I've got the ability now via the GUI on the 4670 to reset the changeover unit. And when I do that, all of my Black and Burst outputs become healthy, and the changeover unit now reverts back to the primary. But the Grandmaster is still on the backup. And we also now have a priority one recovery. So when we select that, it reverts back to the original priority one setting that was configured in the system. And as soon as we do that, we're now back to having the top 4670 as the Grandmaster and the reference generator for Black and Burst and tri-level sync.
Yeah. This allows the engineer in charge to be able to go in and verify that all the black is actually working, all of your analog and SDI syncs are working correctly before you bring the ECO back, and also get out and verify that everything about your PTP is back and everybody's in sync and happy with each other, so that you are in control of it walking back.
So the next bit, we sort of touched on it there, but we've also added another layer of kind of insurance to prevent unnecessary Grandmaster changeovers. As I alluded to, telecom systems typically utilize what we call self-healing methodologies, whereas broadcast systems require a physical manual intervention to reset the system. So in many situations, this self-healing methodology, return to service switch, offers no operational benefit, and in most cases simply introduces more risk in a broadcast environment. So we need to avoid or delay that second transition, and it's key to maintaining a smooth, disruption-free broadcast IP timing environment.
Yeah, because the the BMCA itself will, without any other help, will automatically switch back to the original Grandmaster. So it automatically sees the change in conditions and would revert back if you don't do something.
So you're familiar with the emergency changeover unit and the fact that you would physically switch from the backup to the primary. So what we need to do is we've added a parameter on the 4670, which is known as enable only once. So what this does is if the device is the Grandmaster and it's deselected for whatever reason, maybe it's lost its GPS antenna, for whatever reason, it's no longer the Grandmaster, but then it returns to a healthy operating condition. With this set, it will not become the Grandmaster again until you manually intervene.
And what brought this about was many systems started having issues where their PTP was coming and going and coming and going. And the system was switching over, coming back, switching over, coming back. And a lot of this was done, unfortunately, by truck drivers who were running GPS jammers because they didn't want their company knowing where they were driving and then drive by your building with their GPS jammer on, which would cause the PTP to switch over. They'd get out of range, your PTP would come back, and another truck driver would be coming by, causing the PTP to fail again. And some systems, even though it's a pretty quick switch, some pieces within the 2110 network don't like the clock ID changing. And when the clock ID changes, they get upset and do things they shouldn't.
So this is kind of just like another layer of insurance that's going to guarantee that you don't get unnecessary switches and, should we say, unexpected surprises, which
Yes.
always happen at the most inopportune moment, don't they, Steve?
Yes. Yes. Yeah, or you get a faulty connection on GPS antenna or something that's coming and going, and things walk in and walk out. So this sets it so you are in control of returning that Grandmaster back.
So we've talked about a lot of scenarios here. Should we look at some real world cases that we've come across? So to protect the innocent, we're not going to name people, but some of you might know who you are. We apologize. But it's by sharing this sort of knowledge that these systems will grow, they'll become more robust, and we'll establish the best practices. So many of you may already be familiar with the Fabrics handheld SX range. Um, there is a product in it called the SX Tag, which has IP capabilities. Now, some of you may already be aware of this, and you may be using this in your facility to monitor your 2110 systems, because it acts with that level of analysis, but it can also act as an IP to SDI and SDI to IP gateway. But where I've found it really useful is basically analyzing PTP, because it's got a beautiful display here that will allow you to go in and see the PTP mode. So all messages that are exchanged via the IP multicast, whether it's mixed hybrid without negotiation or unicast. It's PTP leader, so defines which of the two PTP sources are acting as the source clock. Remember, as Steve mentioned earlier on, not every device can do this. Fortunately, with our Leader and Fabrics test and measurement products, we can connect to both. It's PTP status, indicating here course lock is just frequency locked. Fine lock is both frequency and phase locked. And then we've got the PTP source version. As you can see here, this is version 2. It's got my Grandmaster ID, which is a very useful thing to know. And for those of you who know, that 00090D is leader, whereas if you look at source 2, it's got a different ID. Quality of service, PTP domain reporting, which we touched on earlier. So if you haven't looked, if you've got an SX tag and you've got the IP interface, go and have a look at this, because this is a gold mine of information, isn't it, Steve, for fault
Yes.
finding PTP, and it's
Yes.
handheld.
Yeah. And especially turning up the network when you are using, a leaf spine network, and you've got so many boundary clocks in there, and boundary clocks can change the IDs. It can change, priorities. They can change domains, and you got to make sure that things are 100% set, as Kevin will allude to here in a second.
So here we have an example. So this is a lovely leaf spine architecture. Notice got the PTP distribution layer in it. So what could possibly go wrong? But we're a customer who's reporting issues. On some devices, they had quality of service issue with graphics that were flashing and banging, or they, just it wasn't right. So what we did was we turned up, and I had the SX tag with me, and we plugged it into the back of the PTP distribution switches, and it was reporting the Grandmaster ID that was coming from the LT4670 quite happily. So we then moved down to the spine switches and gradually worked our way across until we came to this one. And this had basically a different Grandmaster ID. So when we did a bit more investigating, we found out that actually the Grandmaster ID was a boundary clock. And if you look very carefully here on this drawing, basically it had not been configured to receive PTP from the distribution layer. So what it was doing was it was saying, okay, I'm going to be basically a PTP island in this. So you can see all of the devices downstream that are connected to that particular spine. And lo and behold, it happened to be this particular leaf here that had the devices that had the major problem on it. So once we got hold of the networking engineer and showed him that it had the wrong Grandmaster ID, he went and did some magic, and instantly that resolved the issue. So, I couldn't have done it without the tag. Or I could, but it probably would have taken an awful long time, Steve, wouldn't it, to knife and fork through that?
Yeah, it would have. And you need to remember that graphics are being run typically off of a key. That key is telling it where to overlay those graphics, and that's pixel accuracy. And if that key starts moving because the phase is different, it's going to give you those jumping graphics.
Yeah. The other thing that we frequently talk to customers about is understanding, the timing relationship between PTP and black and burst, Steve, don't we?
Yes. And there's three aspects of this that you really want to monitor and keep an eye on from time to time, and especially when you're turning your network up. PTP and black both start at the exact same point in a broadcast network. They're going to start at pixel 0, line 0, and that's the beginning of where PTP starts. That's the beginning of where blackburst starts. But within a 2110 network, we don't send the vertical interval. We don't send the horizontal interval. We only send the active picture raster. So we need to make sure that that active picture raster starts at exactly the same place as the active picture starts within your SDI network, or you'll never be able to cut between the two.
And as I said, there's two numbers here, Steve, which people will get to learn rather rapidly, won't they? Basically,
Yes.
line 21, approximately, it's plus or minus two lines, isn't it,
Yeah.
officially?
It's what I found the buffers will handle.
And if you're working with 1080p, it's going to be 42 lines.
And just as an FYI, UHD uses 42 lines because of the underlying structure of it is also 42 lines. So you can see this one's off by one line, and it's within that plus or minus two. That for 1080i, you want that RTP timestamp when the video was created to be that offset.
And the
Now,
other one is our first packet arrival time, isn't it?
yeah, so first packet time. So this is the first packet that's actually read into the video buffer. Now, this is actually the super critical one because this is where the processing starts. This one has to be correct. And in this case, you can see this one even changed lines, but it's still within that plus minus two. And some devices out there won't read the uh, RTP time. They only read where is black and where is first packet time. But I have found that some devices need that RTP time because they use the RTP in order to find the first packet time. And without finding RTP, they can't find first packet. And without being able to find first packet, they can't process the video. So you
So,
need to
I mean,
verify all three of these functions in checking your timing.
and the great thing is, Steve, on the Leaders N series, we've used the crosshair display that basically every broadcast engineer is going to be familiar with from
Yes.
SDI video.
Yes.
So, so there you go. It's something that you're familiar with, but now displaying new information.
Yeah. And you can't rely on your multi-viewer to tell you if things are in time or not, because multi-viewers are just basically, if you will, FIFOing the data. They're taking the data in and throwing it on screen, and they're not using PTP to present the data on screen. So your PTP can be way off. It's like having SDI in non-external reference mode, where it's just taking the SDI data and presenting it and not using external sync to actually position it correctly. And it will not tell you that your PTP is way off until you throw it into your switcher or your graphics device, and it won't work.
You get that immortal line. I've got network traffic, but I've got no picture.
Yeah,
So I think, Steve, we have somehow done remarkably well here.
we have. It's a lot of data, folks.
And so I've not been monitoring the chat while we're doing this. I'm hoping that Cindy and the team have. And we might be in a position to take one or two questions. Cindy?
We will, as we mentioned before, we will answer every single question, even the ones we might answer right now. Kevin and I will go through every single question and get back to you. So you got one or two there, Cindy?
We do have some questions. Yes, absolutely.
I'm sure we've got a lot.
Yes, so many. So we'll get back to all of you offline. Don't worry, we got your questions and we will take care of you. I cherry picked a few and see if you like any of these, Steve and Kevin. Question about testing the failover. Is it as simple as cutting off the connection from the Grandmaster?
Well, there are a
Well,
number of failovers, aren't there, Steve?
yeah. So if you're talking PTP, removing or having an issue with your GPS will cause the clock class to change, which will cause a PTP failover. yanking the fiber out of the back, just dropping PTP will cause but it's going to be a hard changeover because the unit's going to have to see the loss of announce messages and then change over. So you're going to lose PTP for about 3 cycles, and then it will change over. It's the same as what would happen with baseband signals. In that, yes, I can either screw up black and it's going to change over, or I can remove black and the ECO is going to change over. So there's kind of multiple scenarios, but you always need to test the GPS one because a lot of people just yank the GPS or the PTP off the back of the generator and make sure it fails over and don't think about making sure that the priorities work correctly by pulling the GPS off. That's the critical one, really. Kevin?
Yeah. So we have a white paper that we've published that talks about I think there are 6 fail scenarios from, as Steve said there, simply losing GPS, pulling a fiber, losing power to the SPG or even to a boundary clock switch. They're all documented, and if you go onto our YouTube channel, we've also done some videos showing these various scenarios and how basically the service can remain uninterrupted. So what we'll do is we'll get out to everybody the link to that white paper and also the link to the playlist on the YouTube channel. So yeah, it took a while to put those together, but hopefully you'll find them useful.
Okay, Cindy, you probably got time for one more.
All right. What minimum test equipment do you recommend to verify PTP synchronization and SMPTE 2110 flow timing from day one?
You have to have a waveform monitor that is a 2110 waveform monitor that has all of the PTP measurements in it. And you want to be able to graph those PTP measurements out over time because network issues can come and go. And you want to be able to look what happened an hour ago, especially in the case of a live system and something happens in the middle of the night and somebody says, hey, we took a hit last night. Well, you'd like to know, did my reference change? What caused that hit? And you can go through all of the layers of the system by looking at the graph charts and see which one took the hit. And you know where to start looking.
Because the great thing, Steve, is you can set the event log timing to be PTP.
Yes.
So it's tallying with all of your other monitoring systems, so you can go back through those and basically frame accurately look at when something happened. Thank you once again, Steve, Cindy, and everybody for putting this together. It's
Yep.
Somehow we do it, don't we?
Kevin and I have a blast doing these, so we love doing them. So we will get to all your questions and get those out in the next week or so.
So watch out. We're thinking about what comes next. Little hint, maybe. Seems to be a lot of cinema cameras appearing in live production, isn't there, Steve?
Yeah, there does. That's been a hot topic lately. Is how do you deal with cinema cameras in a video broadcast world?
Yeah, I mean, as I said, you've got a major sporting event coming up in about 3 weeks' time, haven't you?
Yes, we do.
So apologies to any Seahawks fans out there, but I do follow the Rams. So
being in LA, so do I.
So thank you, everybody. We'll see you all again very soon, and we look forward to working through your questions.
Thank you very much.